Alrighty, so here's our modular prosthetic arm presentation by myself, Kip, and Alex Fager. Alright, so here is how the servos are gonna correspond to each finger of the hand. Thumb B1, index 2, ring finger 3, and so on and so forth. Here's the initial flow chart of the user application. We decided on 3 different modes. The first being the cylindrical grasp or grabs, where we would be using to carry stuff, water bottles and other cylindrical objects. And then we will have a peace sign, which would be using only 2 and 3 servos, 2 and 3, to replicate a peace sign, and the last one would be guns up, and we'll do that by activating servos 1 and 2 to replicate the guns up. And here is a video of how we are plotting this data, and you'll see as...
So right now Kip is in a resting position, we're reading 0, and as soon as Kip flexes, there, we see an increase in the bar graph, and as he remains flexed, it's on there, and when he starts relaxing, as he is right now, the bar goes down, so, yeah.
Cool, so just talking a little bit about it, the sensitivity and kind of like how placement really matters here. So last week we had it on the under kind of lower forearm area, and it was very easily to control. But when we had it on the bicep area, any little kind of movement in your hand or forearm or arm at all is going to affect your bicep. And so, like, even if I just move a finger or just a couple fingers, it's going to throw out or send a signal or create a signal to the sensor. And so it's very sensitive there. So we're experimenting with different placements.
That was last week.
So here's the 3D printing progress. So we waited a bit for the filament order to come in on Friday. This is just black PLA that we can use more for the project. In the meantime, we 3D printed some fingers and labeled them. Basically, the fingers we printed last week, we kind of mixed some of them up as they look very, very, very similar. And we also need to reprint the fingertips with less support and print off some of the covers for the arm. The fingertips we printed last week were kind of scratchy and a bit annoying to use. So since they're going to be, touching the objects and are going to, be out in the air so we can look at them, we want to print them with pretty high quality. So we'll reprint those with this new filament. So here's the pre-assembly parts. Basically, we put them in little baggies and labeled them so we don't lose them this time. So here's what an assembly of fingers look like. Basically, the hole size is around 3 millimeters. Of course, plus or minus a little bit. 3D printing is not known for the absolute best of tolerances, so it does take a little bit of force to get in there. But we have these little pegs that go in and basically secure the parts together. We're probably going to print a lot more of these and probably possibly even design our own specific use case for them. So here's a little bit of a picture of what it will look like whenever it's attached to the hand and how far back it can actually manipulate itself. The important note here is the holes. Going back to the last image, you can see here that the peg really isn't all that long. And the palm is going to need a peg that's around 3.4 inches long to attach all of the fingers together, as it's just one straight hole line. So we're going to need to print that out pretty soon. I'll go design a custom piece for that and print it out. So we're going to hopefully have all of the fingers on and attached correctly by the end of this week. One of the small issues, which is the reason why we're reprinting, is that some of the holes on the inside of the fingers, which is where the fishing line will eventually go through, were a little bit warped or had something blocking them, which is of course a bad thing, as the fishing line does need to go through it cleanly. Which is a quick budget, and that is the end of the presentation. Thank you.